In this example, we're going to find the centre of mass of a lamina created from the area as shown, and I've put on a blue dot and called it x bar, y bar, and that's where my centre of mass is going to be. For this example, I'm simply going to use the two given formulae. You should learn these formulae, but as you'll see in a later video, you will see how to derive them, and you should also know how to derive them. Okay, so we can see by looking at the two formulae, they both have one thing in common, and that's the denominator, which is simply the integral between a and b of y dx. In this case, y is equal to e to the x, and my limits are 0 and 2. So I'll calculate that first. Very straightforward integral, and we end up with e squared minus 1. Okay, I'm now going to find the integral of xy dx between 0 and 2. So I've put that in. I've got to now integrate x e to the x dx. I'm going to use integration by parts. By all means use the quick methods I showed you in class, but nonetheless you'll end up with x e to the x minus e to the x, putting the limits in, and we end up with e squared plus 1. The next thing I'm going to do is find the integral between a and b of a half y squared dx. So putting that together, I can see that I'm going to be integrating a half between 0 and 2 of e to the x all squared dx, which first of all I'll rewrite as shown, and again a very straightforward integration. Put the limits in, and I end up with e to the power of 4 minus 1 over 4. And then the last job is simply to use the formulae provided. So in that case I'll get that x bar is equal to e squared plus 1 over e squared minus 1. And for y bar, I will get e to the 4 minus 1 over 4, parenthesis, e squared minus 1, close the parenthesis. In an examination, that would get you full marks.